So what is the purpose? I want to hear one keyword. What is the purpose here? Help me out, guys. I have a lot of interesting things. If we do it faster, you will see many interesting things. Otherwise, I have to cut short. So help me out.
Authentication.
Exactly. Credibility. Authentications. Credibility. 2-3 people are reviewing it and giving a credibility. It is not biased by my own mind. Do you understand? The credibility in the market, that my work is selected by other folks also who I don't know, right? Because these are anonymous reviewers, typically. Okay, so it gives a credibility, and submission happens, then review. Typically within 30 days, it comes back, and 30 days is not for reviewing them. I take 15 minutes, but it takes 30 days to go in the system, to get assigned, and I get a chance to review it. I take 10 minutes and I reject it, due to some reasons, right? Which is 30 days is the maximum time. Good journals I'm talking about. So then it goes to the reviewers. If it gets further handling, that it is a good paper, it goes to the further reviewers. Typically 2 or 3 in numbers, maybe more. Once the reviewers comes, the editor does the following. May I ask a reviewer to elaborate? Sometimes the reviewer gives backs the comments, and editor says, no, this is not sufficient. I want more details about why you are accepting or why you are rejecting. Because you have to give as a reviewer, you have to give your decision, whether you accept or not accept, right? So then you have to give your reason, solid reason. I accept because of this adding an innovation of this type, explicitly stated statement. Or I reject because of this results is not adding anything new. It's just one more exercise as classroom exercise. And handling editor is the one which directs to the reviewer. It can send back to the reviewers and say, I do not agree with you have done 2 rounds of readings, and it doesn't I don't think that you have read the whole thing. Usually editors are very expert in that area, so they know, they can read the gist in a very quickly manner. Although they will not evaluate each and every line, but they know. So they can go and call back the reviewers again and again. Okay. So, but within 60 days it comes back, and authors get the revisions, and then the process can. At top journals including Nature, the Lancet and PLOS Medicine, have you heard of these names? All of you? Or these are mediocre journals? You have not heard. You have all heard, right? Lancet, Nature and PLOS Medicines are top-notch journals, not because they are published in Europe or America. They are top-notch because the way they have a rigorous, transparent policy of selecting an article is outstanding. It's outstanding. They are transparent. They are very clear. Sometimes they publish their reviews on their journal. Okay. So almost half of the papers get rejected on a desk. That means it is not going further for the review in these top-notch journals. Reviewers don't reject bad science. They are not rejecting the bad science. Mostly they are rejecting the bad writing, not storytelling. You see the distinction there? You will think, oh, my paper is because they think my science is not good. That's not the case. Most of the time it's the writing. But nobody pinched me. Oh, writing is an issue. Writing is an issue. Okay? Today I am pinching you guys on this aspect. There are lots of submission types. Original research papers, right? Review articles, case studies, comment. Is it interesting enough or no? I can skip also.
Yes.
Yeah. So these are standard types. Original research papers. Do you know what is this commentary and perspective? Has anyone done commentary and perspective? I do it a lot. But again, you have to know the field quite a bit in order to write those things, and a journal to accept it also. So it takes little time. But these are shorter articles. These are not full-fledged research. Okay, so these are very important aspects which give the visibility to your work. People will get to know your work by these two things. There is also rapid communication. What is rapid communication? As the word says, it is rapid, right? During COVID times, I was publishing in 14 days, 15 days, very fast review process, because it was important for modeling purpose. My model work was getting used in the state of Florida, for example. So they were publishing it randomly, very rapidly. Okay, so this rapid correspondence is also there. We don't know these things. And these are very important segments of you should write it, these things with your mentors. You may not get called because you don't have an experience for these things, but your mentor will be, because that person has been in the field for some time. You got my point? Okay, very important. So, and it gives a storytelling. This is all about storytelling as a salesman. Okay. I want to go. What do I want to? What does all this mean to you? So cover letter we already discussed about. When we submit the journals, we need to have a cover letter. You see, this is one of the cover letter. I want to submit this manuscript, title this, authored by, short title this, authored by this, and then I write the focus of the manuscript. I don't know if you guys can see it at the back, but it's very tiny, but I'm reading it. Okay, the focus of the manuscript is, and then there's a whole paragraph on innovation storytelling. I'm selling it to someone, editor-in-chief or handling editor, who doesn't know my work. He's probably from some different area. So I need to be crisp, smart, and also say words that sounds like a salesperson selling things. Otherwise, the person will not have a salary at the end of the day. Salesperson has a very tight deadlines, right? If they don't sell, they don't get even a penny, right? So this is very key aspects. And then I also write 3 more lines. The potential reviewers. I gave some names, although it doesn't. It is not a guarantee that editor will going to choose the reviewer for sure. But I listed out my potential choices for the reviewers. Typically, when I am a handling editor for a journal and I have a papers, I assign out of 3, 1 from that list. What the author, this is an author letter, right, to editor as a cover letter. Do you understand this letter, all of you? Yeah? Okay. What else do I have? That's it. And then thank you. Of course, you should thank you to everyone. So, okay, how do you choose a journal? Very difficult task. How do you choose a journal? Do you guys have any problem with finding a journals in your first papers? If you have published? It's a very challenging. So how do you choose it? Let's start. How do you choose a journal?
Based on keywords.
But keywords, okay, keywords from your paper, and you're matching it with what?
Scope.
Say it again?
Scope of the journal.
Scope of the journal or aims of the journal, right? So usually they have a paragraph long on the about the journal, right? Yes, you look into that. What else? Is that sufficient? You will match to the nature also. Will you going to send? Or you will match to a very mediocre journal also. So which journal you will choose then?
Impact factors.
Okay, fine, impact factor. One is the impact factor, but that should not be the only one.
Only editors, and who is the handling editor? And
well, sometimes yeah, you can choose it. Sometimes that you once you submit it, it randomly assign the based on the you will not know the handling editor. So that is something is tricky. Okay, but you can, if you know, then that's one thing you can do. What else? You know, so again, think about this. I think you are going in a different directions, guys. If you are thinking that my goal is let's publish and that's it, then you should do that way. Where is the shortest route to get published? But I just told you that that should not be the goal. Your goal should be that it is not falling in that 80% never cited work, in 20% cited work. So what should you do? That it should be a perfect match, not from the from your that okay I get one more line in my CV as a publication, but it is really useful. So the wider audience who will going to read that paper. You know, this is very important aspects that I am trying to stress upon. Which journals will give a wider audience to your specific research? That is a very key aspect. Okay, there is journals. For example, there is a journal like Royal Interface. There is a Royal Society, is a British society. It has a journal called as Royal Interface. It is very interdisciplinary. If I send my mathematical papers, nobody will read there. Why should I send there? Even though it has a high impact factor, even though Royal Society is very good, why will I send there? Nobody will read it because the audience of that is more interdisciplinary in biomedical sciences. You understand? If I am thinking of mathematical, I may try dynamical system, for example. Not because, they may have, and by the way, more theoretical journals have lower impact factor. That doesn't mean that they are bad journals. It's just that theory get less attention than applications. You got the point here? Okay. So it is done by aims, but it is also done by the audience that I can broadly say. So even though it will be a small, very low impact factor journals, people might not, but audience would read a lot, I would send it. Why do you post your studies on LinkedIn? Because more people will read it. That's why. Right? Okay, so now reviewer response. Once you go, again, this is not about journal. You have to respond every day on an email to some professional way. How do you respond it? And this is a basic essence and that one as a professional researcher should know. For example, if someone says, I have reviewed your paper and there are these issues, right, in a paragraph format, right, few things he has listed it out in the paragraph. How should you respond? How should you respond to that email or message? Yogesh, how did you do it last time?
We looked at what were the reviewers' comment and we break it into every single point which is arising, and then we sort of. So,
but what do you mean by break it down? Break it down, you have done it, I know, because I've seen it. So breaking down, what you mean by is a mapped responses. What that means is, even the person has written in a paragraph format many problems with the things that a person has reviewed. You will write one problem as number one and response to the first problem, then second problem as number two, and the response to your response to the second problem. Mapped responses. Do you understand the difference?
Yes.
If you lump it together in a paragraph, it will dilute your focus and responses. So this is a mapped responses. So response, again, this is a journal example where there are multiple reviewers and I am giving a response to each one of the reviewers, and reviewers has told me many questions, many problems, and each of the problems I am listing down, giving my solution, listing down and new solution. Do you understand? This is called as a mapped responses. This is not only true for journals. This is also true for simple messages with the professional settings, in the email settings, in a colleague's response. You should do that way. It's all of a sudden improves the readability and thought process, quickly getting to the point. Writing. I think there are different people write in different ways. Again, this is a picture from the web. But what I do is, this is what I have designed it. It's called 3223 method. And this is something that I think worked for me. I mean, of course, people will work in different ways. So, you know, you all know, I don't want to go into details of each section, and you all know. But 3223 means this. 3 points, at least 3 points are important in introduction, at least 2 points are important in methodology, at least 2 points are important in results, at least 3 points in the discussion section. And what are these 332? I'll explain you in the next slide. So these are 332, at least. Again, these are at least. This much has to be there in each section in order to build a story. Otherwise, you do not have a story. If you do not cover this. You got my point? So let's take an example. 3 things in the introduction is what has been done in the literature on that topic, the topic that you are talking about. What has been done by other people, not by you. That's one. Second thing, what is the research gap? What people have not yet done in that area. That needs to be highlighted. Any study, any research I'm talking about, these 3 to do. Research objective, what is your goal? What you plan to do in that. This means 3. You can see that in introduction, this is 3. Now, 2 in the research. Again, this is at least I am talking about. You could have more points. But if you have these 3, you are crossing the story, you're making a story from your work. That's what I'm trying to press from. 2 things. Data use. Where is the data sources coming from? What are the units of it? Describing the data. Right? It could be your input data, it could be your validation data, it could be simulation data. You have to define because you are taking the data from some other sources. Method, exactly. Oh, I use statistical analysis or regression analysis. I use dynamical system. I use delay differential equation. Whatever that you have used, you have to tell the method. So these 2 is at least has to be there. Result. In result section, there is always your primary goal and there is secondary goal. If you lump everything as your primary goal, you will dilute. People will not even find it fun to read the papers. You should know what is your primary goal. And that should be highlighted quite a lot. Secondary goal will be few lines only. More things about secondary in the appendix. Focus yourself when you are doing the work on this. Discussion, 3 things. You repeat the objective of your research. That's 1. You compare your results with other study. That is a validation. And third piece is the limitation. There is no study in the world that comes without limitation. There is no study. Every study has a limitation. And you should know your weakness. Because if you know your weakness, reviewers will love it. They would say, oh, he knows, the person knows, he or she knows the limitation of the study. They would not reject your paper. You already know the limitations. Maybe try to resolve some of these things if possible. If not, then it is okay. That's the way journal reviewers will write. Okay, so that is very. Don't hide the limitation. When you hide the limitation, then reviewers get mad and will going to highlight so much of your limitation that it will eventually reject it. Okay, you guys want to get water or something?
Chai, sir.
4:45? After 13 minutes. Is it okay if I continue for 13 minutes? And then we will drink tea? What do you want? It's your choice. I'm okay with anything. Let's see the raise of hand. Do you all want? I continue for 13 minutes? 3 minutes. 3. Okay, so since majority voted, I'll go by majority. And let's continue. I bet you have not seen what I am about to show. So pay attention and write it down, because many things I talk, but I don't have it on my slides. You might get the slides or recording from there. Okay. Anything I write it as IMD. Introduction, method, results, and discussion. When I say anything I write, what does that mean? When I write emails, I have IMRD, professional. When I'm writing casually, that's a different thing. But I write emails, I have IMRD. There's an introduction to my things that I want to discuss. There is method, what I plan to do for that. It could be, I have a meeting, I will take you for that meeting, that's a method. I will take you to that point is a method. I mean, method doesn't mean always differential equations, right? It's the analogy that I am connecting to any text. Abstract is IMRD. Introduction is also IMRD. Method is also IMRD. Inside method is IMRD. Discussion, results, everything is IMRD. You just have to understand what is introduction for that section, what is method for that section, what is result for that section, and what is discussion for that section. Okay, this is true for presentation, this is true for anything. Can you see the relation there? That way you can never miss the storytelling part. These are the methods to make sure that you are not missing the heart of the issue that you are dealing with someone. 20%, less than 20% of the people follow, fraction of the people follow IMRD, and it is the most important thing. 50% of the editors and 1/3 of the reviewers follow IMD. Anyway, I mean, this is what I'm trying to okay, how do we read an article? How do we read an article? How do we quick read the article? Let's say this.
And conclusion.
Loud, so that everyone can see.
We can read abstract and conclusion to understand an article.
Okay, abstract, good. Again, it depends on what you mean by quick. 1 minute quick, 10 minutes quick, or half an hour. Typical one good research paper, if you want to read line by line, it would take few hours. It will not be that because it's someone else's research, right? You have not done that. But if you want to do quick review, that means anything less than few hours is quick read. Then it depends on how much time you want to spend. You might want to spend 5 minutes quick read. So what do you do? Please write abstract is the first thing. Before abstract something? Title. And then? Well, after title.
After title, abstract. Then
Keywords is also. Why are keywords used, by the way? Why are keywords used?
search.
For
Easy search.
the search purpose, because that's how they link. But so that means people are searching using these things. These are important words. And that's why it is keywords, right? It's not just words. It's keywords. So those are the things you have to look, right? And then comes the abstract. And then what?
Last paragraph.
Last paragraph of introduction. Very good. Why did the last paragraph he decided? Not by you.
Novelty. Something new.
We have the research gap.
Well,
Structure of the paper. They
research gap is not in the last paragraph.
Structure of the paper.
Yeah. So what did you say?
Structure of the paper.
Well, structure is also okay, but I think it is the objective, research objective is in the last, typically in the last paragraph. Second last paragraph is what? Research gaps. Exactly, research gaps, isn't it? So, again, that's why he said last paragraph, because you don't know what is the objective of it, then what are you doing? I mean, you don't want to do methods and everything, and then you talk about research objective. It makes no sense, right? First thing is the research objective, right? Then what? Then what? Say it again? I can't hear you. But method is a very big place. So what method? How should I check? I mean, remember, I have 5 minutes. I have 5 minutes, quick read, 5-10 minutes, let's say. So what should I do? What should I read? Or what should I go over it?
Instead of looking at the analysis, like I'll be looking at the analysis, like what and all they have done.
But how? How will you know that? You're right, but I want to hear some words which I'm not getting it. So,
Methodology.
well, we will see a pictures, right? Pictures is 1,000 words. We always say that. That means it tells you what are the results, right? It quickly tells you everything. Otherwise, you have to go read it and comprehend it. It's not written by you. Remember that. Okay. And then what?
Numerical results.
Yeah. So figures of a numerical results, right? Right. Anything else? Tables, yes. Picture, when I say picture, it is the table also included in that. Tables and pictures are quick read, and it gives you a good perspective of the reading, of the paper, right? What else? Again, 5 minutes is still not, you have 5 minutes, maybe 3 minutes left.
Data sources.
How will you know that? You have to read. Yeah, if it is in a bolded letter written, then that's a different thing.
Application part, sir.
How will you know that? Where is the application? Do they put a title of the application? No.
Mentioned in the report.
Okay, so again, there are different ways. Someone said discussion or conclusion section. That is one thing, but quick reading in, because discussion sometimes is long discussion. So, how is discussion parts written? Discussion section written. What is the first paragraph of discussion? Objective. Our objective. What is the second part? Results. What is the third part? Say again?
Comparisons.
Well, once the result is there, then you need to talk about validation. You need to say, how is your result comparable with other studies? Right? That's the next paragraph. Limitation comes after that. Right? So, again, it depends on what your focus is. You can choose the paragraph. If a person knows how to write it only. Sometimes that is not written in that order. Then we can't do much. But usually I'm talking about a good journal paper. It should be written in that format. Now, how do I look for next paper then? If this paper is important paper, then what should we do? Right, so we look at the citation, right? And then go about, looking those citations. Okay, anyway, let's go further. This is what it was about. Have you read annotation before? How many of you have heard of the word annotation? I do it in every reading, by the way. You will be surprised. You have heard?
In biology.
Well, it is true for anyone, irrespective of discipline. Annotation is very important. Okay, let me show you what this annotation means. Actually, I have the review process. But I think who will talk about the review? You will be talking about? Okay, he will be talking just mesh term and all those things, more details. But this is annotation. Look at the details here. If I am reviewing the paper, this is how it needs to be reviewed. If it is truly on your topic and you want to understand that thing, this is annotation. Annotation is your notes, handwritten notes. Now there are even PDF tools. You can highlight, you can edit directly in the PDF. You can use that. That's the same thing as writing handwritten notes and taking a printout and handwritten. Annotation is not taught in our classroom. I'm sorry to say that. It's very important ingredient in the professional world. We do it all the time in industry. We all do all the time when we are faculty, full-fledged faculties. Is that okay? So annotation is very important. Okay. How many of you have heard of Equator? Nobody, I think. Equator is a network of researchers who have, in a world over, it is very famous. And Equator is where the guidelines are stored. How to write a paper, how to report the results. These are trained, there are already published papers on that. We don't know about it. Let me give you a list of the guidelines. These are reporting guidelines. Again, this depends on many different things. Have you heard of systematic review? There's a guidelines called as PRISMA guideline. Okay, there is, again, these are study protocols. What is protocols? What is protocols? It's a very important thing in biological, biomedical, healthcare. You name the medical health related fields, public health, protocol are must. What is protocols? Who knows what is protocols?
I guess there are certain
Rules.
You have written protocols? You have not written protocols. Okay. Anyone else?
So in general, if you are doing research on some animal or plant, you have to follow some general guidelines. Is this coming to protocol?
Well, it is not only true for only animals and this thing, it is even true for mathematical results. But we don't do it because we are never told to do that. That's the problem.
Protocol is something like in cloning experiments, you need to follow that.
Correct. So cloning, word he's using cloning. That means if you leave this document here, other person who is not aware of this research and follows step by step will able to produce things exactly as it is. Step by step. What software you use, what equation you use, where is this equation come from, what is the mechanism in it, where are the data, all these things are written step by step in that. That's called as protocol. Now it is very common in fields where the experiments are done, but it is not common in physical sciences or mathematical sciences. But it is important, very important. Okay. If you write something that other person can redo it exactly, you are an excellent writer. Okay, because sometimes you think that you are understanding very much and you skip telling it explicitly to the other person. It happens with me as well. Okay, so there are these, and these are all the, again, you go to this website, you will find all the guidelines, variety of guidelines for doing the research work. This is very, very important, and Cheers is one of the guidelines. Cheers 2022 is the latest one that comes out. It is a reporting guideline for research articles. You will see it has how should you write title, how should you write abstract. These are guidelines for, and these are published paper. Cheers is a published paper that tells you how to write title, how to write abstract, how to write these things. Just what I am telling you here, and in a quick way, they would take a few pages long description about how to write it. I use a lot of these, and I think Yogesh will talk about it in his lecture on this, how to use these packages AI tool we are using a lot for doing literature review. And we will give a hands-on also, right? Yes. We will give a hands-on experience on that. Okay. I think I want to stop here. Yeah, thank you. So we'll take, there's a coffee break, or who is there? I think. Coffee, tea break? Yes. There's tea break, no coffee.
No coffee, just tea.
Also, one important thing. Today is the first day. Use this as an opportunity to spread words that how actively involved you are by posting yourself and the things you have learned on the social media. This is a beautiful way, Can posted this advertisement of this since they posted it the last time, because they are doing it repetitively. Last time 2-3 days, I got like 40 emails, messages, and I'm not joking, I'm serious about it. This is a good way to build your network. You can have a picture of yourself. You can talk about what you have learned. You can talk about, oh wow, I didn't think this way. Anything interesting that you feel like, you can talk about it. That way, and this is a good way to actually get used to the social media also. I write blogs also, by the way. Yes. So, okay. I stop. I will not talk
Recording off कर दे.
Order it rather than doing simultaneously everything, right? Okay, good. Anything else?
I am Adi.
I am RD, okay, he mentioned, okay, good. Anything else? That's it?
Images are more
80-20 you said.
In what
What's the
sense?
purpose of
Right, so you focus on making the impact of 20%, and so you have to think about a value of the things that why you are doing, basically, right? What else? Anything
images add more value than long paragraph or words.
Correct. So images, that's a quick reading. Anyway, so that means we did learn something unique. It was not a boring session. Okay, so now I think this lecture you will not see it in any modeling course. And I have thought over it a lot to prepare something on these ends. And this is trivial but very effective piece that we will talk about today. Okay, and it is model thinking. How do we think about modeling? Okay, before I go, how do you structure your day? Now, who was listening to me when I was talking carefully, when I was talking in the morning, in the first thing in the day, in the afternoon? What is one word I used? Let's see if someone remembers that. I just talked like for a few minutes, right? When I was during the inauguration, right? What is one word, key word I use? It's very important you have to chew the words that a person is speaking. This is very important. Say it again.
Valuable.
Okay, value is vendor. Right. We don't hear that. Value is a really very important word. Good point. What else?
Communication.
Communication. Very good point. 2 words. But this is not the word I am thinking of. Okay. Well, value and communication gives you a structure also, right? I use a word holistic. Holistic. Now what that holistic means is when you do the model, you are good modeler not just by knowing the mathematical equations, right, and doing the analysis. That doesn't make you the good modeler. The good modeler is someone who knows how to communicate, someone who knows how to plan yourself, someone who knows how to write effectively. These soft skills. These soft skills makes a person a holistic modeler. Holistic word, have you heard of holistic? HOLIS, right?
Yes.
Holistic. So it's a very important. So I am making a comprehensive modeler, not only by analysis, not only by simulation, not only by writing a ground equation. That is not my task only. Okay, and this is very key aspect. So how do you structure your day? How you structure your day is, how many of you do that? Can I see a raise of hands? How many of you every day structure your day? What does that mean? Plan your day. You do it, okay? And how do you do that? No, you can see, sit and talk. Yeah, yeah. How do you structure it? I mean,
or some task and
so you write it down.
no sir.
Okay. So
I write
again,
it down.
you write it down.
Yeah.
Okay. So writing down makes you clearly, and you will not brand new. Again, that's a good thing that you are doing that one. But then next step is to write it down also. This is very key, and this is we get lazy. And we are not saying you guys, but I also get lazy. Okay, and we need to be structured it very good. So let's see the structure means. 1 minute planning saves 10 minutes of execution. And that's a known fact. That's an experiment done by the social scientists to find that 1 minute of planning saves you. You know, many times we do mental exercise of modeling. Oh, that assumptions is good, this is, and then 2 seconds later I forget about what I thought about, right? Or when we search for something in a Google and not write it down, we research it again a few minutes later. It happens to every one of us. So that 1 minute of planning we are not doing. Okay, so this is very key aspects to the modeling exercise also. Again, I want a person to be effective. Now I also teach mental health in my modeling class. So holistic doesn't mean only structuring the day. I do talk about sleep. I do talk about exercise. These issues are also part of the modeling exercise. In my classroom, I give a graduate level and undergraduate level modeling course, and I do bring. Sometimes I bring the mental health specialist in my class, and sometimes I know some things that I can discuss about, and that is coming from a published work. It's not that I am making up the story, by the way. Okay, so it is always said when I work in industry, it is trained, and I'm working with some of the good companies in US. I'm trained in last 10-15 minutes of the day at 4:30 p.m. They ask us to write it down what you will do it in the next day. Usually 4:30 the office closes, but they don't let you go, and they let you choose that time to write down what you will do next day, if it is a working day next day. Otherwise, a Monday. If it is Friday, because it's the 5 days a week work, right? So that is very important. That saves almost half a day. That planning saves half a day of wastage of time if you don't do it. You will see the huge difference. Okay, and that is what I mean by order priority. Now here also come 80-20%. We do. Again, this I don't want to go there. This will kind of fill up the whole things, but this is very scheduling and planning ourselves for the next day is very key aspects for the modeling. I want to go in the next slide. I think there's a lot of things. I want you guys to see these videos. It's called Millionaire Schedule. How the millionaires schedule their activities, and that's why they're millionaire. You know what is millionaire? People very rich. Why do we? Now it's not about money. I'm not talking about money here. I'm talking about what makes things successful in the life. The success is meaning different for different people. It doesn't mean always money. Success could be, oh, I finished a good modeling paper published in Lancet, for example, right? So that is what I mean by, if you look into these videos, if I'll play it, it will take minutes, but it's truly, it's a cartoon video. It's a cartoon, but it's an eye-opener for you. You will be amazed to see, oh, I never thought, these things happens every day, and I never think about these things. Okay, so I will share these slides, so you will have it by tonight. So you can feel free to go over them at your own pace. Okay, and it's not about rich. Don't take it in the other way. I don't want, of course, if you will become rich, share with me the money, that's okay. But that's not the main goal I am trying to focus on. What are jobs looking for today? These things. And do we know these things? We think that we know it, but truly do we know it? Okay, so for example, algebra. Most of us are mathematician. I mean, she's anthropologist, so she would now. So we have certain strength, certain other strengths we need to fill. In today's world, you all need all these things. You cannot say, oh, I'm good in mathematics and I don't want to run programming. Or I don't want to do communication, right? And I'm good in maths, so I will be successful. No, you will not be. You have to have all of them tick marked at a very high level. And this is not algebra, for you it is casual if you are in mathematics major, algebra is casual. But if you ask some biologists, algebra course was very tough for them. College algebra I'm talking about, not abstract algebra. If you know what I mean by difference in the two. Right? So, what I'm trying to say is, these are basic critical threshold that you need to know in today's job markets. Now when I say program, the AI comes in that. It's a common language nowadays. But you should not do it blindly also. People are using AI blindly. Again, we have Dr. Anamika will be talking about some of these AI tools that are good, but again, how you use it and in some class later on. But these are very good. Get involved. Remember this research skills that I was talking to about? Get involved in this research. So these are all these are 5 skills. It's published in Forbes magazine. And these editors of these good New York Times, Washington Post, Forbes, they do a lot of research to write down the articles, simple articles. They do lots of research. So they go to the social scientists, they go to take a surveys, and from that they write it down these. So they have statistics, they have citation in their. So I just put these things as a list here for you to see. Now I want to talk about the modeling evolution, the method evolution. Can you guys see it from the back? I don't know if it is very bright or. Is it possible to close this light actually? Really very too bright to pitch on the. Is it better? Yeah? Okay. So, एक कप कितना कप कितना कप
ये मत करो
अगर दिख रहा है तो सही it's okay. So what it is showing is a time evolution. This is 1930 to 2010, and this is the time when things starts to what field starts to become popular, and how long it took to become to its really mature state. Right? For example, probability theory and stochastic process started around 1930s, and they evolved during this period of time till 2000. They evolved a lot, but after that it is kind of almost negligible in some sense. I mean, again, there are studies happening, but not as much as it was happening during that period. And then dynamical systems started around 1940, a lot. During this time, it is quite a lot. It is work. And then operation research is more young field, more young. It is started around 85, I think. Yeah, 85. Right. So it is going from 1930 to 2010, by the way. Okay. So there's combinatorics, graphs, operation research, graph theory. Now, history tells you many things. I get very fascinated with how people have studied certain things, and even in the disease modeling, and I will show you the history, how things have evolved a period of time. That helps me think about what are key aspects people were looking at different times when the tools were less mature, for example, how they were thinking. So these are the things very key. My area has been stochastic process and dynamical system, those two areas. My dissertation was on stochastic process, and I use a lot of infectious disease dynamical systems, by the way. So I have edited books in stochastic processes, and I worked with my PhD advisors. I had two PhD advisors. One was a well-known expert in infectious disease, and the other one was considered as queen of probability. So they are very old now, they are in 80s. But I was lucky to be exposed to two different topics. Okay, and statistical mechanics is also relevant. You know, if you see the title of this course, it is many things. It has global health, it has statistics, it has mathematics, it has computational science. It's an intersection of something in the middle, right? And so we don't understand other side of the world very well. We have to know those things. Okay. This has becomes key research area, differential equations and in the modeling. Of course, there are different models, but these are more popular in the modeling nowadays. Current methods are using these complex networks. You know complex networks? Okay, we have a lectures also, in one of the lectures on complex networks. You will see it for the disease models, basically. And then, you know, what else is there? Combinatorics also we are using to some of it. Dynamical system, of course. Now, this is since 20th century. This is 20th century, the whole century we are talking about. 1900 to almost 2010, right? Here we are talking about after that, how things have, in the last part of the, because lots of research has been done, so how things have evolved. So complexity science, the word complexity science started to pop up in 1980s. It is used also in mathematics, also used, it is also used in physics, it is also used in computer science, right? So complex systems people use. Agent-based model, have you heard of agent-based models? Anyone? Very important topic. In the agent-based models, there's two types of models: micro-simulation models and agent-based models. Micro-simulation models also have individual modeling. Agent-based model also have individual modeling. In micro-simulation modeling, there is no interaction between the two people. In agent-based, there is an interaction between the people. That's the difference. There are two types of models. If you model things, suppose if I model how all of us are behaving here, or maybe something is spreading, ideas are spreading in this population, then this is an agent. Each and every individual is an entity in my model. Okay, so that's an agent-based model. Because you will interact with each other, therefore it will be called agent-based model and not micro-simulation. If each individual do their own things and not interact, then it is called, for example, people going in the hospital, standing in the line and going in the hospital. Everyone go and do their job. They don't interact with each other, right? So that's a micro-simulation model. Does that make sense? Remember that, individual. Population, there are two types of model, population levels and then there is an individual level, right? So I'm not talking about population level where you aggregate people and you talk about population. Here it is individual I'm talking about. So there are two types of model, micro-simulation and agent-based. Agent-based has interaction and micro-simulation does not have interaction. By the way, last class we will talk about agent-based also. Multi-agents, now we are talking about multi-agents. Have you heard of the word agentic recently?
Yes, agentic AI.
Okay, what is that? Anyone else has heard? No. Agentic AI you have not heard?
It is like make.com and doing the automatic task like sending emails, WhatsApp to
Correct.
users.
ML, machine learning.
Right. Machine learning is a method of learning, right? But agentic AI is multiple agents doing task and bringing it together to do a bigger task. For example, if I want to buy an air ticket from here to maybe Dehradun to Delhi, right? So that task will be going to the website, searching the website is one agent, getting the different airlines is one agent, getting the cost of the airlines is another agent, right? And then finding the shortest minimized cost is the fourth agent. So there are different agents finally coming together to tell me what is the best price to buy or giving me the best ticket to buy from Dehradun to Delhi. So it is called as an agentic AI. Multiple agents coming together to doing a very complex task. Getting an air ticket is a complex task by a machine, not by us, but by machine it is. Also for us it will take many hours, by the way. So it is called multiple agents. And we do in mathematics this thing. I build a model where, and I will show you the website tomorrow actually, I am not prepared to show right now, but I will show it tomorrow. So I will show how people are interacting in that movie, and you can see that it's a think about it as a space satellite watching a city, and people are going everyday business, different people, and they are infecting each other of an outbreak. So we mapped a Portland city. Portland is a city in the US, and we mapped it using each agents basically. And we came to know what are the places where people are more likely to get infected. We were talking about flu at that time. It is 10 years old study, by the way. So flu, for example, people will get infected in office more, in a grocery store more, in a school more. That is what our intention was from that movie. Okay, so that is called as a multi-agent model, by the way. Now these things are newer field, but they are primer. The base of these things are evolved from the complex system dynamics, optimization, probability game theory, and event-based simulation, cellular automata. These are different types of models, right? Now again, it's not possible for us to do it in this 1 week course, everything, but I want you to be aware of that there are these type of modeling also, and it has evolved in what period of time. Artificial intelligence is nothing new. Nothing new. It was in 70s, by the way. It was in 60s, by the way. Artificial intelligence. But it was very naive at that time. Right? Like Apple, like what else? Microsoft. These all have big AI models starting 2005, 6, 7, something like it, 2005, 2006, 7. And their things failed miserably because they were not really collaborating with practical scientists. So I'll show you the example in the next class, but there are ways, so artificial intelligence is nothing new, even though we are hearing nowadays a lot, but it is nothing new. It's has a past history. I mean, if we are scientists, we should be knowing all these things. Neural networks. How many of you know neural networks? Why one should know neural network? Now, this is a common knowledge nowadays. If you want to get a job in today's job market, you should know what a neural network is. It's not complicated to know, to not know. What is neural network? Is models behind artificial intelligence. Behind artificial intelligence, the models that they use are called neural networks. Say it again?
Multi-layer perceptron.
Right. So there could be many complex ones also, but the basic idea is called neural network. Okay, which is very important. I can show a diagram quickly since I can see some of you have not seen that. In the next class, I will try to collect some information and show one picture, and you will get a feel of what neural network is. Genetic algorithm. You have done it, right?
Wow.
So, because he's worked in genetics actually. So, yeah, so it is, I mean, genetic algorithms are algorithms that are, because genes are transformed from many generations, right? I mean, I have my father's gene, father has my grandfather's gene, and so on and so forth, and my mother's side also, right? So they are getting evolved over a period of time with some features coming from my ancestry and some from my environmental conditions that are getting changed. So genetic algorithm is based on certain features like these ones, and it evolves very fast, and it takes into account multiple layers of features. Okay, evolutionary models. Why were we not able to capture the COVID? Remember COVID?
Yes.
What was the problem with the COVID? Why were there were so many casualties of COVID?
Strain was mutating, mutation.
Yeah, you are not supposed to give the final
The
answer.
phospholipid layer of the protein was not.
No, not that sophisticated. Yeah, well, that I got it. But my point to you is, we are so smart. Human beings are so smart. But why were we not able to capture?
Because it evolved very rapidly.
Correct. I think you said the same thing. Yeah. So exactly, because the viruses were evolving faster than prediction of what?
Previous
Prediction of models.
models.
There, we were doing the modeling. That's what I'm trying to say. It's not that we don't have any idea, all of a sudden we forget about the model. Models have history of 100 years. We had the idea of models, we were modeling it, and we were doing it a good job, but as soon as we build a model, the strain changes, the infectivity changes, and therefore the model was not anymore good it was good for the old strain, but not good for the new strain. That was the big problem. And all the policy government of India was making, US government was making, was based on models. Every decision they were doing on a daily basis, how many beds we should keep, which population, which intervention I should implement in the population, which population I should restrict from taking vaccine, which population I give most vaccine. These are all decisions on a daily basis were taken by a modeler. There's a very famous professor. I think I would like to have him also in one of the lectures. I will try to see if he can join the panel discussion. He's my very good friend. His name is Gautam Menon. He works for Ashoka University. Exactly. You know him also, right? So he's very well known. He writes articles for Times of India, Hindustan Times, and all these things. But he's a physicist by training. He's a professor at Ashoka University. But he was modeling for COVID, and his model was called Bharat Sim. And that policy was decided based on his models at that time, right? So I will try to see if I could have him for a panel discussion. I don't know, but we'll try. So these are the evolution of the models we use. I have used in some or other studies one or combination of these models that you are seeing. Okay. Tipping point. How many of you know what is tipping point means? What is tipping means?
Like in the restaurant we give tips sometimes.
Okay, that's a different one. So, what is tipping point? Tips. If you have a glass full of water and you slowly you try to push, there will be a point when it falls by itself. That's a tipping point. You understand? Tipping point is when state drastically changes to some other state in mathematical terms. Okay. Why I'm talking about that? Because everyday policymakers wants to know the tipping point of a system, of a policies, of a health system, of a hospital settings. Everywhere what they are aiming to answer the question is about when something breaks or when something they cannot handle it. They want to know that so that they can plan, they can budget it. You understand my point? So there's a very famous book by Malcolm Gladwell in 2001. It's called Tipping Point. How many of you have done mathematical epidemiology before? Disease models? Disease models, right? How many of you know about tipping point then? I mean, at least those people I'm asking. You know what is tipping point?
In dynamical system,
What is it?
when we can say bifurcating point.
Bifurcation.
Bifurcation, exactly, bifurcation point. But what I was asking was in mathematical epidemiology.
Reproduction number.
Say it again.
Reproduction number.
Reproduction number. Reproduction number. Why is it called tipping point then? I don't understand.
It's an average number of things.
No, but why tipping point? Why it is called tipping?
There's a threshold, after that it will become epidemic.
Correct.
It's below 1 means
So
endemic.
the state changes. No infection to big infection. So that point is called reproduction number equal to 1, right?
One.
So that's why we call it, that's a part of an example of tipping point. I have a chapter which only talks about variety of tipping point. Vectorial capacity. I don't know if you guys have known about it. When there is a, how many of you know malaria, right? You know dengue. How is it spread? Mosquitoes.
So,
There is a tipping point in infection through the mosquito also. They bite many times, but there has to cross that limit in order for it to become an outbreak. We calculate it using mathematical models. Okay, so there is it is called vectorial capacity, just like reproduction number in epidemic, vectorial capacity in vector-borne diseases.
Ali effect.
Ali effect, yeah. So there is a threshold, right? It's a bifurcation basically. It's a bifurcation that is happening. Ali effect is happening on one side, on the other side there is nothing, right? So that's what is, that point is a tipping point. Absolutely correct. In ecology. Excellent. Yeah. So in real life, okay, let me, do you have any examples in real life that you have seen tipping point? It's a very important concept because, as I'm saying, all models is talking about risk. They may not call it as a tipping point, but it's exactly for example, in vaccine, we are trying to find when will the vaccine going to eliminate the disease. It's a tipping point of the vaccination. You understand? It's a different terminology we are using, but the behind the scene, the essence is tipping point. What other things? Can you give an example of your real life?
When we go to the bed before sleeping, the point at which our mind gets
Okay.
here.
Well, that's okay. That's good. Yeah.
Minimum
Okay.
passing marks.
Huh?
Minimum passing marks.
How is that so? Explain me.
In exam, 40 marks.
Oh, it's a great. So I see. So if the 40 marks is a threshold you have kept, right? But that is a fixed thing, right? That's not, see, in the reproduction number or vectorial capacity, or these things are decided by environmental variables. It's not a fixed thing. Well, what you are saying is always fixed. Whatever the instructor fix it. It will not change by natural phenomena that is occurring based on number of students, or whether students are weak, whether students are turning their sign. It will not change. It will remain the fixed. But that's not a natural tipping point. It's like a artificial tipping point. So I'm talking about natural tipping point. Any one very important example, we see it in everyday's life. Have you gone on the street and you go and there is a fight happens with anyone? Sometimes it becomes very big and sometimes it doesn't happen. I mean, people just walk away. Right? It's a tipping point also. Now we don't understand why sometimes it becomes a big things. I mean, you driving and then something happens, scratch happens, and then people start shouting, and the other times, okay, bye-bye, nobody cares. There are many social factors that makes it things to tip, basically.
So we'll close within 5 minutes,
Okay, fine.
then we'll continue tomorrow onwards.
Okay, fine. Fine. So this is tipping point is very important. By the way, I was talking about roids. Remember roids? There was Gen Z roids in Nepal. Have you heard about that?
Yes.
Something happens in Bangladesh also, right? Why did this happen and not happen? Equal intensity there happened in other places, but never become this big issues. But sometimes it does become. That's a natural tipping points. We do it mathematically, these things. In ecology we do it, just like Ali effect he was talking about. In epidemiology, just like reproduction number. In social science also we do it. as I was talking about roids, right? You name the system and there are tipping points. And the goal of a modeler is to calculate formula for this tipping point. And that is the model thinking. Okay, very quickly, model for biologists is RAT. The terms, the language is very different. You don't understand these things that when you talk to a biologist, you'd say model. He will not say equation, as mathematician will think equation. The biologist will think RAT. The social scientist will think about flow chart. For model, the flow chart is for engineer, it is a toy. Caricature of a big thing. It's a model. So you see the same word, different terminology in different language, different fields. Make sense? So that's why we have to work with the other side of the word. I want to work with him because I want to work with anthropologists because I don't understand that language. And even though they will use the same word, but it might have a different definitions in their language. Okay, and that we will get to know only when we work together. Okay, so anyway, I have a lot of things, but there is some books that is very important. How science works, collapse. These gives a different perspective of what model is about. Okay, I think since I will stop here, I will not go any further. These are some of the courses that I would highly recommend. But one thing, as I said in the afternoon, that beginning of the, again, I will share this slide, so don't worry about it. I will share this slide. You can get a good idea, you can understand. I think I have done an okay job in explaining it, and you might be able to read it and understand it. But if not, you can always ask me. Since we have 5 minutes, I can use 5 minutes?
Yes, sir.
5 minutes. Okay, so tomorrow's task for all of you is as follows. We have to do research projects. Okay, so what tomorrow, first thing in the day, we will be circulating a sheet of paper, and I want the names of one group. Again, we are not assigning you in a certain groups. You choose your own group. Try not to be in the same institution as you are in. Try. It is good for you. Choose someone new, someone that you don't know as a group. I'm looking for 6, 7, 8 people in a group. Again, number could be plus minus few numbers, which is okay. But at least 6 people. At least 6 people in a group. And form your group and think about some problem of interest. I will start with some examples of an applied field that will help you again, once you choose a topic, you will discuss with us and we will going to help you reframe the research objective for that research question. It could come from a social scientist, social science, it could come from anthropology, it could come from genetics, it could come from biomedical fields, it could come from any random field, I don't care. But it has to be a novel, interesting question that you all agree to work on. How you will do the questions, research on it, that's a secondary, don't worry about that. It should be. All of you have done any research? Has anyone never done the research? Never? Okay. Never? Okay, that's fine. We will all help each other. Okay? We will help each other, right? We learn some, we are not born with all these skills. We learn from them. Is the point clear? So what is the task tomorrow? That we talk to each other, right? And we choose our group. 6, 7 people at least, right? Per group. And we are forming, again, research question is, I don't expect everything to be done by tomorrow. It will be phrased better as we go in the next class. And I will show you some examples. After seeing my examples, you will see, oh, I can work on this also. Oh, I can work on this also. Not only on infectious disease, not only on oncology, not only on, I worked on, as I was saying, roids, for example. I worked on why Gen Z outbreak happened in Nepal. That could be an interesting problem. What I will help you with is revising your research question in a credible way, which is publishable work, plus then we have to think about the equations for that. Is that clear or partly clear? If partly clear, I think we have achieved the goal. Yep. So that way force us to even talk to others. Okay. Okay. So thank you very much, and we'll see you guys tomorrow.